In this section, we're going to talk about a topic very important in physics. It's called vectors. Now, vectors have both magnitude, which means the amount, and the direction. Scalars, on the other hand, have only magnitude. So we've seen this before. Speed and velocity, we talked about that briefly. Velocity always has a direction associated with it. Speed, on the other hand, is a scalar, and it only has a magnitude, 50 miles per hour, for example, whereas a velocity would have to be 50 miles per hour west, or something like that. Another example of a vector is a force, and forces also have both amount, 5 newtons, and direction, east, acting in the easterly direction. To add the vectors, combined vectors, you must include the direction. So you can't just ignore the direction and add them arithmetically like you can with scalars. You have to take into consideration the direction that the vectors are traveling. The sum of vectors is called the resultant, and you'll hear that word a lot in this video and in the reading. Vectors are represented by arrows, as you'll see in a minute, and they're added using something that's called the tail-to-tip method. Very easy, and we'll talk about that in the next slide. Okay, now we get into adding vectors. Okay, the simplest example is when you have two vectors that are acting in the same direction. So you represent each one of the vectors by an arrow, as you've seen here, and you combine the arrows, or you string together the arrows, tail to tip. So in other words, the tail of the second vector here is connected to the tip of the first vector here. Now the resultant, or the sum of the vectors, is just simply where you started to where you end up. So in other words, you start here, the tail of the first vector, you end up at the tip of the second vector. So this length from here to here represents the actual magnitude of the resultant, and that's what's shown down here in this green arrow. Now, with vectors acting in the same direction, actually you can do it arithmetically by just adding them. However, that only works when they are acting in the same direction. Okay, now suppose they're acting in the opposite direction. So we see here we've got two vectors. We've got this red one over here, which is acting to the right, and the shorter one here, which is acting to the left. Notice that this second vector is connected to the tail of the second vector is connected to the tip of the first vector, and then the resultant of the two vectors is this right here. Notice that this vector is acting to the right because that's the larger vector here was acting to the right. Now this, in this case, if you wanted to do this arithmetically, you could just subtract the two vectors. So when two vectors are acting in opposite directions, like east and west or north and south, you can find the resultant simply by subtracting the magnitudes of the two, and then the direction is going to be the direction of the larger vector. Now vectors don't always act in the same or opposite direction. Here we can see one or two vectors that are acting perpendicular to one another. So there may be a force. This one may be acting north, this one acting east, and we are seeing the two vectors with their tails together, and you'll often see that in problems or in drawings in textbooks. Now if you want to find the resultant of these two vectors, you still use that same tail-to-tip method. So in other words, you've got to take this vector and you've got to move it so that its tail is connected to the tip of the second vector, like we've got it drawn down here. And then once again, the resultant of the two vectors is where you start to where you end up. So this green arrow here represents the sum of these two vectors. Notice if this one is acting north and this one is acting east, then this one is acting somewhere between the north and the east. Now the last thing we have to talk about with vectors is this notion of the components of a vector. And the components of a vector, as we see here, are the horizontal and vertical parts of the vector that results in the original. It's sort of like the reverse of finding the resultant. So for example, here is this vector over here, and these two pink arrows represent the horizontal component of this red vector and the vertical component of the red vector. And there will be more examples of this in your reading.